Hello friends, so today in this video we will create a food classification model and we will create a CNN model from scratch here. Okay, so let's get started. To download the dataset from the Roboflow, it's we require the Roboflow library. Then here we will download the dataset. Let me first run this cell. Okay. Okay, now let me download the dataset. As you can see. Okay, let's take the time. Please wait. As you can see, the dataset name is food one, but we don't. I want to change this, or you can say rename it. So how we can do that? Just as the old name is food one, and the new name will be this one. Okay. So if os.path.exit old name, if the old name is exit, and not means new name is not exit, then rename will be performed. Otherwise, this message will be okay. Now let me run it. Now folder name is change. These are the libraries which we require. Okay. Now, and device means it's at a device, whether we have a CUDA or you can say the CPU. It means it's required that all the model images labels has to be on a same device, whether on a GPU or a CPU. Otherwise, training will not perform well. So that's why, or you can say training not perform well, or you can say the error will be thrown. So that's why we have to first check if torch.cuda is available. If it is available, the device will have a CUDA variable, CUDA value, or otherwise it have a CPU value. Now let me run it. The device which we have is, you can say it take time for running. Please wait. Okay, the device which we have is CUDA, means GPU. This is a test directory, as you can see. Sorry, not test, train directory. Let me open it, the folder. Okay, so this is a train directory. Now let me run it. So inside a train directory, you have 20 folders, which is the class names: burger, butter naan, chai, chapati. Okay, so these are the name of the class names. Okay, now we have to create a custom class which basically return the images and label. So how we can do that? Let me run it. Let me close it. So here we go. You can say define a custom dataset class inherent from the PyTorch dataset. So here we use a dataset here. Now first we have to initialize the everything. So how we can do that? First constructor method to initialize the dataset. Root directory. The root directory which we have is the train directory. Transformation means any data augmentation or converting to tensor, everything. Okay. So initially it will be none. The root directory give me the root directory variable. Transformation will be initially will be none, and the classes, how many number of classes which we have. How we can do that? When we get a train directory, basically a train directory is a root directory. When I will pass it, I have os.list directory, give me the all the folder name inside it, and the folder name is itself a classes name, so it will be give me the sorted classes name. And how we can, what is happening here? See, for id, when we enumerate over the classes, this Salzburg classes. Okay. And it's give me means for this it is example. Let me show you. Burger, pizza, and sushi is like a list. And when you will enumerate an idx and you will use class name, burger will be mapped with 0, and you can say pizza will map with 1, and sushi will be mapped to 2. So this will be class 2 index mapping will be done. Now initially the sample will be empty. Now, what is use sample? I will explain you. Initially, empty list to store the image path and label both. For each, you can say image path, or you can say image and image path with its label. How we can do that? How we make a pair of it? So first of all, we will loop over the classes, and you already know that class is basically it's itself a folder name. So when you will use os.path join and root and join with the root directory and a class name, we will get a complete class folder name, and inside that we will check if it is exit or not. If it is exit, then we will loop over the class folder, means to loop over the class folder according to the number of images present in it. So how we can get an image path? For getting the image path, we will use last class folder, means this one, the folder name path, and inside it the image name will be given by this image name variable when you will loop over the OLS directory class folder. Okay. So after getting the image path, we have to loop over it, and you can already know that class folder, it's itself a class name, and you can say the index or label will be stored in this class to index variable. So how we can do that? So first of all, sample dot append, we append the image path, and it will class to index using this variable. We just pass to the classes. Okay, we will get the index value, and ultimately we map the image with its label. We will do for each folder, for each class name folder we will do it, and for each, so this way we will get each image with its label. Okay, then we will get the length, means how many number of basically when you will return the length of the sample, you will get how many number of images is used for the training purposes. Now get a symbol means get item basically return the image with its label using the idx. Okay, by index. So when you will pass this idx to the self.sample, you will get the image path and label, and you will open that image with image.open, and if it any transformation is required, we will apply the transformation to the image, and ultimately we will return the image and the label. So this with the you can say the image folder dataset, you can say class is required here. Let me run it now. Dataset is not defined. Okay, let me, so let me import it. How we can do that? So torch.utils dot data import dataset. Okay, so this way we imported it. Now let me run this cell. Okay, it's working very well. Now we have to plot the graph. What is this graph basically give me? That how many number or how many number of images is present in each class name folder. How we can do that? It's very simple. First of all, we will make a count dictionary. Oh, what is user weight? I will explain later. Then we will loop over the train directory. Okay. Whenever we will loop over the train directory using this OS lost directory, it gives me the folder name inside the loop directory. After that, we have to I want to get the entire path of the class name folder. So how we can do that? Just give the os.path.join, then a train directory, then the folder name. You will get a folder path, complete folder path. When you will when you will use os.path.is directory, means if it is exist or not. Okay, the check if the current item is actually a directory or not. We will check it. After just checking it, we will make a list using this. First of all, this os.list directory folder path, it give me the list of all the images present in that particular class name folder. And when you will use this length function, it give me how many number of images present in that particular folder, class name folder of that particular class name images. Okay, so after that getting the image count, we have to make a count dictionary. So count dictionary will be mapped with the folder name and the image count inside the number of images present at particular folder. This way we get a class, you can say the count dictionary. You can see easily see when I will print the count dictionary, you can easily see that a fried rice here, fried rice basically 252 images, pakora 177, pani puri 86. Okay, so this way we make it. Now how we can plot this? For plotting this, we have to first make the list of all the classes. So list count dictionary dot key, give me the all the classes name, and count the dictionary value, give me the all the values for each class name folder. Then how we can plot that? For plotation we use plot.figure. Figure size will be 12 by 6. Plot bar, we have to plot the bar for classes and the counts. Okay, then x label will be classes, y label will be number of images, title will be this, x table will be rotation will be 90 degree, title layout, and show. Let me run it now. So this way it give me number of images present for particular class name. Okay, as you can see that number of images present is pani puri is very less. It's around 90 or 80. Okay, let's come. Now we have to create a data set, or you can see the detail loader, which is required during the training. Okay, so how we can do that? First of all, we have required transformation. If we I have to apply some transformation on the images. First of all, the transformation which I have to apply is transform resize. We have to resize it to 60/60, means each images. The first combination layer which we create from scratch, inside that we be input the image of size. Image size will be 60 by 60, and I have to convert that image into the two tensor, means from 0 to value, scale pixel value to 0 to 1 only. And one more thing, that the image dimension from HWC will be changed to CHW when we use the two tensor. And after that we have to normalize this, normalize image using ImageNet mean and standard deviation. Okay, we have to normalize those pixels values. Okay, so we use mean, standard deviation, this one. Okay, for RGB channel, this is RGB channel, standard deviation for RGB channel, so that's why it's having a three values for mean and standard. Okay, because image have three channels, HWC will be the channel, or RGB, red, green and blue. Okay, so that's why it's have a three values, mean and standard deviation. After we can say making the variable of transformation which we require to apply on our images, we have to create the object or class name which we have created. This will be the train dataset with the object. As you can see, in a construct, in a initialization, we have to pass the root directory and a transformation. So here we pass the root directory. Here root directory basically you know the train directory, and transformation will be the this transformation which we require to transform on images. After creating the data set of the you can see the object of the class which we have created, we have to use this data loader function. Inside this we have to just pass a train data set, and batch size means 32, means when you will run the training, then all the images has to be in batches, and each batch has a 32 images, and they will shuffle through. Number of people workers 2. What is the number of worker is thread for loading data, parallel loading. So that's why for parallel loading we require number of worker will be 2, and pin memory will be true. That's why. So this is a data loader which we have created using, which we use on our training purposes. Now let me run it. So this video train loader is we get what is this train dataset dot get item 0 dot shape, and when you will run it you will get the size of the image 360 and then you will get confused that what is happening here. Here 0, let me explain you. Okay, see this get item we have one variable. You can say this is idx, so we have to pass the, for whenever I want to call this get item, I have to pass the idx. So here I pass the 0 index value. After passing the 0 index value, I'll get the image. Okay, I get the image of batches, so I have to pass this 0 for first image, then dot shape give me the shape of the image, then the train loader, length of the train loader give me the number of batches present at. So we have a 126 number of batches. Okay, and 126 number of batches means is there, for each batch 32 images is present. And when you will get the list, means when you will get this I want to know the number of classes which we have. So how we can do that? Just list directory, train directory, you will get the number of classes which we have. We have 20 classes. So how we can get the classes name? So how for that, it is very easy. Just you have to use the train dataset object dot classes, give you the class name of for your training purposes. So when you will print it, you will get a number of list of all the classes which we have. We have a classes of burger, butter naan, chai, chapati, chole bhature, etc. Okay, now we have to plot the images with the you can say with the label. How we can do that? First of all, we have to create the iterator. We have created an iterator. When you will use the next function inside the iterator, you will sorry, not inside, when you will do inside the next function, you will use the iterator. You will get the samples and labels, and here when you will print the length of sample and label, you will get the sample and length have shape of 32, means 32 images is present in samples, and 32 image labels is present in labels variable. What I want to plot is 16 images. So for how we can do that, for plotting of 16 images, I have used plot.subplots, 4 rows 4 columns, means 16 images. Figure size will be 20 by 16. Figure basically represent the entire subplot. Okay, and axis basically is in a 2D format when in this line, and when you will use axis.label, it will be in 1D format, and why I have to convert it, just for the ease of iteration over the subplots. Okay, now I want to know the class names. So train dataset.classes, give me the class names. It's just I want to plot the 16 images, so I have to loop for 16 times. So that's why when class name, when you will use class name label I, and you already know that where it is gone. What is a class? See, Here class basically get item when you pass the IDs, give the image with the label, and label is 0, 1, 2, 3 be using this class 2d class 2 idx. Okay, so that's why when you will use label I means for the first image, if I am talking about the first iteration, label I give me the image label dot item, give me the image label in integer format. And when you will use in class name, you can say list, it give me the class name of that particular image. After getting the label, we have to plot it. So how we can do that? Access dot I am show, then a sample I dot permute 1 to 0 means permute. Why we use permute here? Because when you had applied the transformation to the images, it basically convert the dimension of images from HWC to CSW. So before flotation of the images, we have to require the same dimension. So that's why we have to use permute 1 to 0. It convert the HCHW dimension of the images to HWC. After that, we set a title label, and this way it's plot the images, 16 images, as you can see. Okay, and you can see the images is not that is blurry, or you can say not very clear, but because the image size is 60 by 60. Okay, now we have to create the CNN model from scratch. For that purpose, we require those two you can say libraries, torch.anon and torch.anon has anon, torch.anon function has f. Now for that purpose, first of all is required class CNN neural net. Okay, then the anon module we have to apply. Then first of all, we have to initialize all the layers which we want to from which we want to create the complete CNN model. We have to initialize it. Okay, first of all, see initialize. Here we are just want to initialize that which layer we required, and after that in this def.forward, in this function we basically connect those layers. Here initialization, here just we want to initialize how many layers we required. In def.forward we connect them. Okay, so first of all, it's required number of classes which we have is 20. It's required here. And super dot, first we call the call parent class constructor. For that we have to use super cnn self, then init. We call the super, you can say the parent class constructor. The first layer will be convolutional one. Okay, and you can say the input image shape will be 3 RGB, and it will be size 60 by 60. It's already fixed. It's already fixed because in transformation dot resize 60 by 60, which each image will it's resize each image to 60 by 60. So that's why the first layer input channel will, input size will be 60 by 60, but end channel will be 30, because because we are not using a grayscale images, we are using the colorful images RGB. So that's why the input channel will be 3, and the size will be 60 by 60. If we use the grayscale image, then the channel will be 1. Okay, so that's why here. Then how we can apply this? Just to use self.convolution1 is equal to anon.convolution 2d, and the input channel will be 3 because we have a RGB channel. Output channel will be 16. Okay, output channel will be 16. Kernel size will be 3 by 3. So let me show you one image. Okay, so this will be the convolutional. As you can see, this is the input image. Okay, this is, you can see the filter will be the kernel filter will be 3 by 3. Okay, so this is a kernel filter. Okay, so this will 16. When you will see, suppose this is the image, this one, this is the image, and this is the filter by 3 by 3. When you put this filter this 3 by 3 at this position, you will get 16, and this is the calculation here going on, how it's going on here. Okay, so let me come back to the code. So this is the first layer which we required. Kernel size will be 3 by 3, output channel will be 16, and input channel will be 3. Now we require a max pooling. So how we will define the max pooling. So that's purpose we use and.maxpool 2d. Its kernel size will be 2. What is the use of max pooling? Let me show you. So this is a use of max pooling. Suppose this is the output of some layer, output of first layer, And when you apply the max pooling of 2 by 2, basically it will go to here, this area, and it will check maximum value. So its maximum value will be 20, so this will come to 20. Here maximum value will be 30. Here maximum it's come to 30. Here maximum value will be you can say 112, 112, so it's a 112. And here maximum value will be 37, so here 27. So that's why it basically decrease the dimension, so which we required. Okay, so that's why you use a max pooling here. Max pooling layer with 2 by 2 window reduce spatial size of the by half. Okay. Now we have to initialize the second layer. For initialization of second layer, first we require the input size of the second layer. And what is the input size of second layer? Will be the input size of second layer will be the output channel of the first layer. So here the output channel of first layer will be 16. So it act as the input channel for the second layer. So it will be the inputs, as you can say, the input channel will be 16 and output channel will be 32. And here 3. Why will we have a 3? Because kernel size will be 3. It's up to you what you want to cap with kernel size, and you will do so much hit and try method. You will get to know what kernel size you have to put. But here I am just putting the kernel size will be 3. Now here again max pooling of size 2. Then third layer. Again for the third layer, output channel for the second layer will be act as an input channel for the third layer. So that's why when you see that output channel will be 32, say it's act as an input channel for 32, and here was 64 will be the output channel, and this is a 3 channel. And here also again max pooling with size of kernel size will be 2. Now we have to define the fully connected layer. Here these are the 3 convolutional layers. You can say convolutional block. Okay, after that we apply the fully connected layer. How we can do define the fully connected layer? First of all, we apply the flattened layer. Flattened layer to convert 3D feature map into the 1D vector. Let me show you. This is so suppose this is, you can say, the pooled feature map, or you can say the conversion layer last input. And when you use a flatten, it just basically convert this 3D into the you can say this, here it is 2D, but when you will basically go deep into it, it should be in a 3D. When you will do use the flatten, it basically convert all things into this 1D format. Okay, so this is the use of the flattened layer. Okay, after flattened, we apply the anon.linear. Anon.linear basically is a fully connected layer. First of all, let me explain you the variables values. So input feature will be 64 and 64 into 5 into 5. Why? Let me show you the reason of it. So now let me explain you how this 5 head came. So let me go up. This is the formula for the h out and width height in dimension calculation for the convolutional layers. Okay, so h in means height input, width input of the images, p for padding, k for kernel size, s for stride. Okay, so let me explain you what is this padding and size or stride is. Kernels, you already know what is padding. Let me show you. So this is a padding. If the padding value is 1, it applies 0 to around the images like this. And what is this stride means? So let me come back with one image. Okay, so this is an image for the stride. If the stride is 1, then the convolutional calculation is performed like this. Means it's here, calculation is done. If a stride is 2, it gap will 2 and then calculation will be performed. So this is a difference between a stride 1 and stride 2. But you can see here is convolutional. We are not defining the stride. We just defining the kernel size. So what is the default value for the padding and a stride if we are using a convolutional layer? So let me explain you. So in convolutional stride, initial default value will be 1 and padding default value will be 0. So we will apply those values in this formula, and we will calculate the height and width of the image after the convolutional layer is applied. Okay, so how we can do it? But you already know that the input size is 60 by 60. It means the output dimension, height and width always remain the same. So how we can calculate it? So let me explain you. For that, the h input will be 60. This is a 60. That's why here 60 plus 2. Padding will be 0. I already explained you why it is 0. Then the kernel size will be, which we have placed 3 here. and divided by 1. Why? Because the stride default value will be 1 in convolutional 2D, and plus 1. After applying this calculation, you will get 58 into 58 into 16, and because height and width is remain same, so that's why. And 16 is a channel because the output channel is 16. Now in max pooling, the stride value will be default value is kernel size. If we do not define the stride value, then the stride value will be the same as a kernel size. So that's why when you apply the formula, its input size will be h input will be 58, which we have calculated here, because convolutional layer is just after the max pooling. Okay, means max pooling is just after before means after convolutional layer max pooling will become. That's why input size will be 58. Then the padding will be 0. I already told you. Then the stride will be has same as the kernel size 2, and the kernel size will be 2. When you apply this calculation, you will get 29 to 29 16. And same way the calculation is performed here, and same way but you will get confused that the calculation is not performed same here. Is that because when you multiply 20, when you divide 27 minus 2 will be 25, and when you 25 divided by 2 will be like 12.5, but here 13 had came because 12.5 is round off to 12, and when you add 1 plus 1 to it, give me 13 here. So this way the calculation is performed, and ultimately this last max pooling layer will be have 5 into 564 dimension. So that's why after flattation I already explained you that where are the images. Let me. So this will be the image after flattening all the neurons, all this values, all these neurons come to this 1D format. Okay, so how many number of neurons will become for the fully connect to means to get the fully connection layer? So how many number of input channel will be there? For calculating it, we have to multiply 64 into 5 into 5. We will get the input channel for the fully connected layer. Okay, and 256 is the output channel which we have decided. Now for the second fully connected layer, input channel will be 256 and output channel will be 128. Now third convolutional layer will be our last layer. So we will use 128 as an input, and we will use number of classes which we have act as a output number of neurons for the last fully connected layer. Okay, so now let me show you. So where it is gone, see. After flattening, this will come number of neurons complete, means that 64 into 5 into 5. Okay. After that, we have created this 256 new layer, fully connected layer. Then this, and last layer will be the number of according to the number of classes which we have. As you can, why we are saying it has a fully connected layer, because each neuron here, each neuron is connected to the previous each neuron. Okay, each neuron is connected to the previous each flattened layer neuron. Okay, so that's why we call it fully connected layer. Okay, so I hope you understand something. Then we have now here just we have done the initializations. Now we have to do the connections. So how we can do that? For that purpose, we use dev the forward, then self and x, where x is the image here. We get the as an input. Block 1, we have to connect the convolutional layer. We'll pass the x, then we'll connect a ReLU. What is the use of ReLU here? ReLU basically is an activation function which we required it. So what is the use of ReLU? ReLU, because suppose this is the input, and when we apply the ReLU, then all the values less than the 0 will go to will convert to 0, and all the values greater than 0 will go to as it is. Okay, so that's why 250, 101, 27, 61 remain unchanged. All these values which is less than 0 convert to 0. Okay, so that's why it's required ReLU here. Apply ReLU activation function. After that, we connect the max pooling layer. Then same way, after max pooling, we connect that convolutional layer. Then here, how we have connected it, as you can see that x basically the image is common in every layer. Okay, in every connection, x is common. Through the x, we are connecting them. This will basically give the flow through the network. How the images flow through the convolutional, we will define here. We are doing the connection here. Okay, so x self connection convolution of x, then x f ReLU, then the pool, and same way for the second convolutional layer, ReLU, then the pool, then third ReLU, then the pool, and then the flattened we have to connect. And then after that, we have to connect the first fully connected layer. then the ReLU we apply here, then the second convolution layer, then the again ReLU, then we connect the third layer, which is the last layer, because last layer have 20 number of neurons, which is according to our number of you can say classes which we have. Okay, so after that it just return the final prediction. Now create the model instance and move it to the selected device. Okay, first of all, model here, just this till here. Using this CNN class, we create a model object. After that, we pass this model object to the device which we have, whether we have a CUDA or a GPU. This is the CNN model which we have created from the scratch. I hope I have explained it very well. Okay, if you get some knowledge, please. Then we will have to know the summary. So this will be the summary when you use this dot summary or summary, and when you apply just pass this model and the input shape of the image, you will get the whole the summary. Here 16, 16, 32, 32, 64 will be the input channel, and this 58 and 58 will be the height and width. And okay, so this is it, and this is the parameters. Okay, now let me run this also. Okay, same way. So total number of parameters which we have is 468,916. Now we have to define the optimizers. So we are using the cross entropy loss criterion loss. Okay, loss function which we are using is cross entropy loss for the multi-class classification, and we are just passing it to the GPU or because to device. Then the optimizer which is used for the aberration of the weights. Okay, model weights. So it's model parameters. Model parameters means all the parameters which is trainable. Learning rate will be initially 0.006. Okay, and epoch value will be 5, because I already had a model which is trained on 550 epoch. I just, for the explanatory portion, I will just train it for the 5 epoch. Okay, now we will now I will explain you how we can do the training. For the training purpose, we use a TQDM was just for the visualization better. Initially the training loss will be empty. Here we store each epoch training loss, each epoch accuracy will be stored here. Okay, now how much number of epoch which we have? 5. So according to that we will make a loop. Okay, according to the loop, and it's required that model should be in a training mode. Okay, so that's why we use model.train, and initial number of correct prediction will be 0, and initial number running loss will be 0. Here running loss is just for the you can say store the loss value for each batch size when you will loop over it. Okay, total sample will be 0 initially. Okay, now we will apply the TQDM. How we can apply it? Just use the TQDM function, then train loader, then the message which we have to display during training. A leap true, yes, keep progress bar after completion. This is the use of the sleeve here. Then we will loop up the progress bar. It give me the data and label. For each iteration, this data and label contain the 32 images images details. Okay, and one more thing, that will pass all things to the same device, to the model, because model layer everything means model images label has to be on the same device. That's why we pass it to this device which we have. Okay, after that here we can say that reset gradient from previous iteration. Optimizer dot zero grade. What is the use of this? I'll let me explain you that. For each batch iteration, if we do not use this optimizer zero grade, then the previous batch gradient value will be accumulated to the current gradient value, and it will disturb the training, or you can say the model training will not perform better. I think so. I have not run this cell. Okay, I have not run criterion. I have run this cell, so why it's happening here? It's criterion. What's the difference between it? Let me solve this problem. Okay, I think there's no problem. So now just we have to pass the image, means in data which we have, to the model. After that, we're using this criterion, means the loss function which we have used. It calculates the loss at how many prediction made by the model is correct and how many prediction made by the model is wrong. We have just passed the output which we have got, means the prediction, and the actual level we have to pass. It will calculate the loss. After calculating the loss, we will compute the gradients values. Okay, loss dot backward basically compute the gradients values. It will not update the gradient value. Basically, it just compute the gradient value. After using this optimizer dot step, all the weight value get updated. Now this all the calculation which we have to perform means running loss. Basically, you can say calculate basically store all the batch loss and will store in running loss. Okay, how we are doing this? Loss dot item into data dot size 0, accumulate total loss multiply by batch size for current averaging later. Okay, that's why get predicted class output dot argument max dimension 1, give me the prediction index with highest longest value. Okay, then count correct prediction in this batch. How much many prediction are correct? We have to calculate it. Just you we have, for that we have just prediction is equal to labels dot sum dot item. It give me that how many prediction are correctly predicted by the model. Okay, how much the prediction is correctly predicted by the model, and argument max basically give me the list. Okay, then after that label dot size means give me the number of you can say the labels which we have. After this is just this whole calculation, this all calculation is performed only for the single batch iteration. When all the batches is completed and all the batches loss is stored in this running loss, we have to calculate the epoch loss. So how we have to calculate the epoch loss? Just running loss divided by the total samples. As you can see, we are storing the total sample here. Then how we have to calculate the accuracy? All you can see this, we have to using this correct variable also. Initially it's 0. Okay, so we have to do 100 into correct total sample. It give me the actual accuracy, and epoch loss and epoch accuracy is stored in this train loss and train accuracy, which we use for the plotation. After that we will just display the masses for the first iteration. Okay, so this is the message which we have to display: epoch, training loss and training accuracy. Now let me run it. So it's get started. Now how we do have to do the plotation? For plotation, epoch log, first we have to make how many number of epochs which we have. For that purpose we have to use star range epoch. It give me the range. Then we have to plot figure ax1. We have to for the first figure we have to use figure.ax1 plot dot subplots. Epoch log will be the x value, train loss will be the y value, then r dash label, and the label will be train loss. X label, Y label, title, legend, show. Same way for the second plotation. Here we are plotting the train loss. Here we are plotting the train accuracy. As you can see, epoch log. Now here just we have to use the train accuracy. After five epoch training, I will show you. Like I think so, it's already completed for the 5 iteration. So don't worry. Before that, this will be the result of the 50 epochs. Okay, as you can see, loss is going down and accuracy is remaining constant. Okay, so now we have to save the model. How we have to save the model? For saving the model, we use first we have to define the path. Then torch dot save model dot state dot dict dot path will save the model. After that, this is not required here. Okay, it's not required. We save the model. Now let me. I think so. Training is completed. Now let me run this. Oh, okay. Rail loss is going down and accuracy is going up. But accuracy is not much very good because we are just trained for the 5 epoch. Okay, now let me save that model. The model is saved. You can see. Wait for the second. See food.pth. Now we have to load the model. So how we have to load the model? For loading the model, we use model.torch load.stateDict. Then a torch.load path means the model path. Then the map location will be the device. Then device will be same. Now here we have the model is in a evaluation mode. Now we have to test the model. Okay, so this way we load the model. It's very simple. Okay. Now we have to test the model. So how we can do that? Just test directory. Then test folder OL list directory means give me the older folder name present in the test directory. As you can see it. So these are the folder name, or you can say the class names folders. Okay, so after that, pre-processing means transformation which we have to apply. See, output shape will be CHW366. Make sure no, it's very compulsory that the input size of the image during trainable, which we have trained, that is 60 by 60, has to be there during testing also. Otherwise, it's throw error. Okay, and squeeze. What is the unsqueeze is because during training we pass the images into the batch, so that's why it's required during testing we have to pass the image into the batch format. So for that purpose we use unsqueeze, which add one dimension to the image. Okay, then just return the image. This is the pre-processing which we required. For the section implementation, same thing. Ax variable train dataset classes, give me the class name, and we have to plot four images. It's no, so here we are plotting the four images, one row, four column. Okay, loop for I don't display for random test image with prediction. Okay, so let me explain you how it is working. Randomly select the text. You already know that test folder, this variable, it's a give me the class name folder. Okay, we have to select randomly class name folder. For folder path, for the complete folder file, we have to use os.path.join test directory and the folder path which we get it. After that, I have to make all the images name, list of all the images name present in that particular folder. For that, you have to use os.list directory. After that, I have to make an image path. For that purpose, os.path.join test directory, then the folder name, then randomly select the image file name from the list which we have created just now. It will randomly select the image path name from the folder we have selected randomly. Okay, after that we will open that image. We have to apply the pre-processing to the image. After that we have to just apply pass it to the in model. First of all, we have to pass the image to the same device where the GPU is. Then we have to pass it to the model. After getting the prediction, we have to use toss.argument output. Give me the prediction of the model. Okay, whether the prediction. Okay, high score means the model which have a high score. That's why we use the argument max. Means the model means you can say the label which have a higher score, that will be the prediction of the model. So that's why you use argument max dot just pass the output. You will get the prediction. After getting the prediction to prediction is an integer format, 0 1 to 3. So how we can get a class name? For that purpose we use class name, just pass the prediction, you will get a label. After that, show the image and set a title. This will be that do the rotation. Now let me run it. This is the you can say the prediction of the model which is just trained for the 5 epoch. But I think so it's working very well. Dhokla chapati dhokla not burger, correct. So it's going working very well. So if you want some changes or make it more robust, either you can increase the combination layer, or either you can increase the max point layer, or you can say you have to work very well, or you have to adjust the parameters, hyperparameters correctly. According to that, you will make a more robust calculation. Just this is a small convolution layer which I just make it just for the explanation purpose, that how you can make a convolutional CNN model from scratch. I hope you have gained something from it. If you gain something from it, or you have understand something from it, please like, share and subscribe my channel. Thanks to all.